Hello, thank you for joining us for Epilog Laser's Engraving Success webinar. What we'd like to do today is capture some high throughput strategies, ultimately to maximize your profit when you're running your laser system. My name is Craig Nelson, been in the industry a little over 30 years. I was one of Epilog's original distributors. I worked on the East Coast in the field for 22 years, working with many customers that are doing majority of the things that you folks are doing today. So I am familiar with the challenges that you face running your laser systems, your businesses, those kind of things. Epilog did invite me back to the factory 10 years ago. Been happily working here in Golden, Colorado since then. Epilog was founded in 1988. It's a privately held company. We still have many of the original owners still working with us today. We're an American company. We currently employ around 150 employees here in Golden, Colorado. We do manufacture our own laser tubes as well as many of our other components right here in Golden, Colorado. It's an RF aluminum ceramic tube. We do that so we can control the quality, the reliability of the tube. It's a very high performing tube that gives us the ability to have the graphics capabilities that we do with our laser systems and have a very productive machine. Today we're going to take a look at productivity, mostly how to keep your laser running. When your laser's running, it's making you money. When it sits there, it's costing you money. So let's take a look at how we can keep it running, and with that, how to increase your production via a couple of easy techniques, whether it's software, optics. We're going to talk about resolution, jigs, templates, those kind of things. We'll get into doing multiples, get into working with our job management software, and a number of things like that. So thanks for joining us. Let's get going. During this webinar, we're going to be discussing a couple of the parameters that we can easily control when operating an Epilog laser to get the most out of your system. I think it would be beneficial if we discuss them a little bit in advance just to give you a better understanding how these parameters affect the operation and productivity of your laser. Specifically, let's take a look at the ramping and dampening of the laser head. Let's talk a little bit about resolution, how that affects things, and take a brief look at optics. Resolution. We've all heard about resolution, 300, 600, 800, 1200 dpi. What does that really mean? Let's use 600 dpi as an example. If I have a solid engraving area, 1 inch by 1 inch, I'm going to use a black square here. 600 dpi, the laser head has to make 600 passes to engrave that area. So it's going to start one side, sweep across, slow down, stop, step down 1/600th of an inch, and then go back the other way. 1200 dpi makes 1200 passes. 300 dpi makes 300 passes. Common sense. 600 dpi versus 1200 dpi. 1200 dpi is going to take twice as long as 600 dpi because it's making twice as many passes. Conversely, 300 dpi makes 300 passes. So 3, 6, 1200 dpi. You can see how lower resolutions can greatly affect your production time. The lower the resolution you can run, the faster you can output your materials. With that, though, making less or fewer passes at, say, 300 dpi, what we get is overlap. So 600 dpi, you can see there's quite a bit of overlap on the engraving. Versus 300 dpi, the spacing is much more exaggerated. That's why it's 600 dpi and 1200 dpi on softer materials of woods, plastics, acrylics. For the same setting, the laser will engrave deeper on those materials just because it's making that many more passes and there's greater overlap, as you can see here. So ideally, we want to run at a lower resolution, but we want to minimize this overlap that we have, or be able to engrave with that enough overlap that we still get good quality. One of the things I've found with these new fusion lasers that I have been able to run them at lower resolutions than the older models. I used to run pretty much everything at 600 dpi. Now I'm running 400 or 500 dpi. Again, greatly enhancing that productivity. But is there anything else we can do to enhance that or help that? Let's take a look at optics. The way the optics work on these laser systems is much like the magnifying glass you played with as a child. Maybe you still do. Most lasers now come with a 2-inch lens. What does that mean? 2 inches, the beam is going to come down at an angle, if you will, or a slope, down to 2 inches, where it basically magnifies or achieves its tightest spot. 2-inch lens, 3 to 5 thousandths of an inch in diameter, burning about 1200 degrees centigrade. A 4-inch lens, that taper is much more gradual, and we're going to get into that a little bit later with our tumblers. But that sweet spot is a little bit more exaggerated. It's a little bit longer to get into that. It's going to be 7 to 9, 10 thousandths of an inch in diameter. Won't be burning at that 1200 degrees centigrade because we get what's called a Gaussian distribution. That means that power density, the area is twice as large, so that same amount of energy is dispersed over that larger area. But we can overcome that with power and speed and those kind of things. But with that, since that spot size is a little bit longer or greater, we can go back here and exaggerate this overlap by using optics. So these are some of the features we can use to operate the laser system. We're going to expand on that further once we start running the laser.
To give you a better understanding of what we're going to expand on further in the webinar, I'd like to run this first piece or this first application. It's going to visually show you the ramping and dampening of the laser system. We do that so that the engraver or the laser can engrave at a constant depth on softer materials like woods, acrylics, plastics, and those kind of things. What we're going to focus on is our little red diode pointer as we engrave this. We can see where it's engraving, but if you look to the left and right, you can see the diode pointer shifting past the area that we're engraving. We call that ramping and dampening. Again, we need to do that so that the laser engraves at a constant depth. So what needs to happen is the carriage head has to go from a starting point, ramp up to whatever speed that we dial in, engrave at that constant speed, slow down, stop, turn around, and go back the other way. So you can see the effect on this one piece that we're doing right now. What we're going to show you later on is as we engrave multiple pieces, we don't have that individual ramping and dampening for each subsequent piece, greatly increasing your productivity on these laser systems. And we'll just let it run. This is a pretty quick piece. I like using this with the laser. The detail is amazing on that. We have great graphics capabilities with our laser systems, and we're going to get into that a little bit more with the tubes that we use and that kind of thing. But you can continually see that ramping and dampening as we go through the piece, and that's what all lasers, or at least all good lasers, need to do to have a good outcome. We finish up. Pull it out. And we can take a look at it. And now we're going on to the next job.
Now that we have reviewed ramping and dampening, resolution, and taken a look at optics, let's take a look at perhaps a real-life application that any one of you may be confronted with. We've got a customer that would like 18 8x10 plaques. These are fairly large. They would like first, second, and third place. Let's go to our Epilog Laser dashboard print driver and get a job time estimation of this. We may be tempted to run this one piece at a time at 600 dpi, but let's see what we can do to change some of those parameters that we just learned about and increase our efficiency. So here we go, dashboard print driver, and we're going to use our job time estimator to figure out what it takes to run one of these in a traditional scenario. It's like 16 minutes. We're at 600 dpi. This is, by the way, our Iris eView camera system. It's live feed camera on the table. This is our actual table. It's pretty cool. Let's look at different scenarios. So that was one piece at a time, 600 dpi. What if we ran 3 across? See what kind of a time we would get on that. We're going to get rid of that. Go to the dashboard. Use our job time estimator. Here we go. There's our job. Out pops the job time estimator, calculating the time. So we're 28 minutes for 3 across. So we did increase the efficiency somewhat. Let's go back to our Corel Draw. So we did one piece. Took us 16 minutes, kind of the traditional way, 600 dpi. Put 3 in. Took us 28.5 minutes. Say we fill that table up because we can. It's our 24 by 24 machine, 2 pieces of sheet stock. Full sheet, full page, if you will, took 57 minutes. So how does that total out for us? So the total job, if we did it one piece at a time, 448. We filled that table up, 3 runs, 6 by 600 dpi, 2 hours, 51 minutes for that total of 18 plaques. So let's change the scenario a little bit. Let's go to 400 dpi. And I'm going to use that 4-inch lens because I want a little bit more overlap on this. Little bit larger spot size. Clean that up a little bit more on that metal. We don't really need to go for depth. But yeah, just a little bit larger spot size, that overlap. We want to increase that. So it looks like, as I'm rambling here, runtime of 19 minutes for those 3. So again, how does that shake out for us? Didn't show up, but one piece took us 10 minutes. 3 across took us 19 minutes, as we just saw. We filled that table up, again, because we can. 38 minutes for that total run. How does that total out for us? The total job, if we did it one at a time, took us 3 hours. But if we fill that table up, 3 runs, 6 per table, 400 dpi, hour and 54 minutes for those 18 plaques. How does that tally out between the two? So 600 dpi, 1 piece per, 448. 400 dpi, if we filled it up, 154. Wait, how does that, what's the difference there? Let's take a look. We saved 2 hours and 54 minutes. What? That's significant, as you can see. And the best part, or the second part of that, is you can use that time that your laser's running rather than doing one at a time to do other productive work. You can do other things. You can do invoicing. You can talk to customers. You can set up the next job, which is exactly what I did when I first started setting this up. So let's go back to our original scenario. What I did is I filled the table up for those first place plaques. This is page 1. I created subsequent pages. Here's page 2, and here's page 3. And I can download all those 3 pages at one time via our either print driver, or what I also did is I save that job in advance in our job management software. So we've got all these different files, if you will. This is my super file, Craig's super file. got it saved right here. I'm going to just download it to the dashboard. It's a big file, just take a second to download. But as you can see, here's page 1. We've got page 2, second place, page 3, third place. I'm going to download all these 3 pages, if you will, or 3 tables worth of jobs at one time to our laser system. Print icon. All of our lasers have 1 gig of memory. You can download all these multiple jobs at one time. They're sitting there waiting for you at the laser. No wasting time going back and forth to your computer. Put the sheets in the machine, hit the go button when it beeps, put another set in. The other job's waiting for you, hit the go button, away you go. It's just a much, much more efficient way of running your laser. And what that equates to is you're making more money per hour with your laser system.
All right, well, let's get to the laser. We've already done our job setup in our job management software. We've downloaded multiple jobs. We are going to use a Fusion Edge 24 today. The Edge is our most popular model. It just seems to be a good compromise of purchase price, functionality, giving our customers room to grow somewhere in the future. I always recommend don't buy for what you're wanting to do today, but buy for where you want to be in the future. So give yourself a little room to expand. We've downloaded all our jobs. This laser has a gig of memory, so you can download multiple jobs on it. We have a thumbnail of our current job. I'm just going to press that, hit the go button, and away we go. So we're going to do 3 pieces at a time here. We are using a 4-inch lens, particularly at a lower resolution to see a little bit better results with that. This job should take about 19 minutes, or about 6.5 minutes per clip. While this is running, we're going to go to our computer and do the setup for the next job.
Let's take a look at another application that we may be able to help you become a little bit more efficient in processing. Tumblers. Tumblers have become incredibly popular. We've got customers that are getting orders for 10, 25, 50, 100, thousands of these at a time. Our rotary attachment does a great job of processing them. However, you're typically limited to doing 1, maybe 2 at a time. How can we get back to that original idea where we're going to fill up that table on our laser system, run multiples at a time, become much, much more efficient, much, much more productive? Remember that 4-inch lens with that elongated sweet spot? Let's take a look and see if we can use that to our advantage. What we found is using that 4-inch lens, we can usually get a logo about 2 3/4 of an inch wide on it without having to rotate the cylindrical item. It's great readability. We still get great results. Again, that 4-inch lens gives us a little bit longer sweet spot to get around the curve of that tumbler. What I want to do is I want to create a template or a jig to nest those tumblers in. Again, so we know where the logo is going to go. We know where the name's going to go. It's going to hold it in place so it's not rocking back and forth. And we can go ahead and put all those tumblers in there. What I create is a cell. It's just an area that I know I can put that in that's going to fit in. We're going to use a piece of foam. You can use a wide variety of materials, whether it's foam, acrylics, plastics, paperboard, those kind of things, but we chose foam today. Again, my cell size is going to be 2.5 by 7.625. I've determined my starting point with an X of 3.5 and Y of 19.215 to create this jig or template. And I've got those already factored in up here on my object position. We're going to have a logo that we're going to place in here. I just played around it to where I thought it looked good, and it ended up looking good at 3.5 and 20.75. So we'll put that in there. That's our logo position. What I want to do is create 5 of these cells to nest up to 5 or however many we want in this 24 by 24 table. Keep in mind there's a myriad of different ways to do this in CorelDRAW. This is kind of a quick and easy way to do it. But what I like to do, I'll go under Window, click on Dockers, and Transform. I know my spacing is 4.5 inches. I've already got that plugged in here. We're going to select these guys. Click Apply. 4 and 5. There's all my cells. It's got my logo positioned exactly where I want to. We're going to nest our tumblers in there. With this basically job, we're going to do 5 at a time. Names. I just typed out the names. There's an imposition feature in the layout we can use to do that. There's print merge. Let's keep it simple this time. We can go into those at a later webinar. A little bit more complicated, but certainly usable if you want to get into that. What I like to do is click on the Snap to object when I do this. Click on that. And what that does is it's going to snap my name right to the center of my cell. Julie. Come on, Mandy. There's center. James. There's center. And Craig. There's center. So everything's centered. Everything's laid out exactly as we want it. We're going to get rid of this part. And all we need to do now is download it to our print dashboard driver in our Epilog software. So take here, we'll download it. What I like to do is download the whole job at one time. We're going to use Edgar here. That's our 24 by 24 machine. In the Epilog dashboard, I can turn on and turn off the different features. We want to cut it out first. So what I'm going to do is turn off the engraving. We've got our vector format set up. I've preloaded the setting that I've used in the past for cutting foam. This is our job settings library. Just click on foam and import it. It's going to automatically import the settings that I've predetermined that work best for this type of foam. Quick and easy. From here, we're just going to print. Goes down to the laser. That job is going to be waiting for us in our gig of memory. Let's do the second part of the job, the engraving. So I'm going to click off the vector. Click on the engrave. Turn it on. Again, preloaded the settings for engraving these things. Here's the tumblers. Import. Preloads all the settings that I've predetermined work best for this type of tumbler. We'll go to print. And both those jobs will be waiting for us at the laser.
So we'll set up our next job. We've got our template already pre-cut. We'll place that in there. And we've got our tumbler. We'll place in the machine. Begin stacking them up next to each other, making it as efficient as we possibly can. We're going to focus it. Since we're using the 4-inch lens, we're going to use our 4-inch focal gauge. And we'll just move our carriage over. Got a red diode pointer. Put that in. And we'll just lower the table until we're focused. With these, using the 4-inch lens, what I like to do is focus to the midpoint So we're going to just move this over right to about there, and we'll focus it accordingly. Right about there looks about right. From there, we should be focused. We've got our job preloaded. And away we go. While this is running, let's go ahead and do some Q&A.
Well, we're back live. That was a lot to digest. Hopefully you got a little bit out of it. We are going to open it up to some question and answers. We've got a couple that have already been submitted. Please feel free to continue to submit as we go along here. But the first question I have is, what is an RF tube? We mentioned that earlier. RF stands for radio frequency. We use an aluminum ceramic RF tube, basically due to performance, reliability, those kind of things. The RF tubes are AC powered versus DC. Conversely, the other tube would be the glass tubes. We can air cool the RF tubes. The glass tubes are typically water cooled, but we typically get longer lifespan, higher pulse rate out of the RF tubes. That's why we use them. If we thought the glass tubes were better, we would obviously use them. We're very confident that our RF tubes are very stable, give great performance, and great reliability. Next question. Use CorelDRAW. Can use other softwares. We pretty much have open architecture on our software. CorelDRAW was a inexpensive off-the-shelf software package when we started over 30 years ago. It does tend to be the industry standard. A lot of people use Adobe Illustrator. You can use CAD programs, those kind of things if you'd like. But it is pretty much open architecture on the software. We don't want to limit you on your application. What I always recommend, though, is make sure the software is going to do what you need to do with the laser. Don't limit your laser's capability by not investing in some decent software. There was another subsequent question down there about light burn. Light burn is very popular these days. My understanding, this is very recent, that we do have a way of working with light burn. So we'll probably have some releases on that in the near future, but I know light burn, a lot of people are using that and all that, and it does appear that we will be able to work with light burn, if not now or very near future. Some of the other softwares that people are using, there's Carpathia out there. A lot of my production people are using that. It's designed for multiple pieces, multiple production, that kind of thing. So there's other softwares out there that if it works better for you, by all means, you're welcome to use it. Oh, Amy's got a question. Okay.
What applications are good for the 4-inch?
Really, anything. What applications are good for the 4-inch lens? Anything cutting applications where you're cutting through thicker materials. Remember that elongated sweet spot. As I showed here, running at lower resolutions. You can do an awful lot with the 2-inch lens, but I do like the 4-inch lens for some of those applications and that kind of thing. It does create a bigger spot size. And again, if you're running at a lower resolution, you get a little bit more of that overlapping, and particularly with metals and those kind of things, it kind of helps clean out whatever residue that you have when you're processing those materials. Also, on those materials engraved from the bottom up instead of the top down, it does do a better job of cleaning those things up. So, another question. How can I get help with these types of applications? That's a great question. On our website, we have our samples clubs. If it's non-proprietary, you can get those files typically. We do have an Epilog virtual training suite available to all of our customers. It's free. There's the Epilog Laser fan group, or the ELFs, on Facebook. That's a great place to get ideas, suggestions, those kind of things. I always recommend getting a demonstration with your local or regional distributor. Make sure the laser is going to do what you need it to do for specific applications and those kind of things. I would insist on this for any laser you are considering. Make sure the laser is going to do what you want it to do. There's a wide variety of applications we can do with these lasers, but yeah, just be confident in your purchase that your laser is going to perform the way you want it to. With that, I always recommend getting good training. You can do that through your regional distributor, particularly if you're a new customer. It's just in everybody's best interest if you get good training. It's easy on you. Frankly, it's easier on us as well. So, but yeah, you can arrange that again through the virtual training suite or your regional distributor. The residue on the tumblers. Yeah, you do sometimes get residue on the tumblers. Blue, for whatever reason, seems to be the most aggressive color that does require some cleanup. Not sure why, formulation or whatever on it. What I like to use is Mr. Clean Magic Erasers, and it's called Blue. It's spelled BLU, powder coat remover. I think I've always had great success using those kind of things. But yeah, sometimes it does take some cleanup to do that, but the Magic Eraser and Blue or some kind of light solvent tends to work really well on cleaning those up, and you get great results. With that in mind, I think we have, okay, here's our first piece, getting back to that resolution issue. This is why I use that 4-inch lens. As you can see, try and get the shut up. We got great results on this. Using 400 DPI and that 4-inch lens. The artwork's fairly large, so not really any fine detail, so that 4-inch lens worked just fine on this. So as you can see, and we did save considerable amount of time. And now, Emily's got our tumbler here. So getting back to the cleanup, as you can see, 4-inch lens, that's a large logo we got, large area that we've engraved. Came out really well. So yeah, hopefully these tips and tricks can help you out a little bit. If you have any other questions, you can contact sales, S-A-L-E-S, at epiloglaser.com. But very much appreciate you joining us today. Hopefully we'll do more of these in the future. Open any suggestions on topics that you'd like